All right, today we're going to be doing Lab 7.2, recovering RC4 encrypted configuration. In this lab, we are going to analyze malware which protects its configuration using an RC4 implementation and recover the decrypted configuration. So we are looking at this explorer.exe within our static and dynamic VMs. The first thing that we're going to be doing in the lab is we went ahead and we ran a kappa scan against this explorer.exe, and we're focusing on the kappa findings for RC4. We have this RC4 KSA finding, and we have the RC4 PRGA finding. So we're going to start by looking at PRGA. We're going to grab the address. We're going to go into Binary Ninja, and we're asked first off what calling convention this is. We can see here Binary Ninja calls us out as a this call convention. And if we take a look at the reference to this here, looking on the disassembly on the right, we can see there are 3 arguments that get passed. And because this is a this call convention, we can see the usage of ECX and 2 stack arguments. So what we're going to do now is we are going to now go into our dynamic VM, and we're going to open up explorer.exe within our x32 debugger. And the first thing that we're going to do is we're going to set a breakpoint on the PRGA function. So let me go back here, let me grab this, and then let's go back here, and let's set breakpoint on that PRGA function, and we're going to go ahead and we're going to run this, and we have stopped right at the function. And so we're asked to review each argument, keeping the calling convention, the this call, in mind, and assess which arguments refer to the data and data size. So we saw 3 arguments. Remember, the first thing we have is ECX, and then we should have something in ESP4 and ESP8 on the stack here. So first thing is let's go ahead and let's dump each argument into our dump window. So we'll start with ECX in dump 1, ESP4 in dump 2, and then this third ESP8 argument into dump window 3. And we can see with the dump argument or dumping argument 3 that it doesn't actually take us to the address that we thought we were going to go to here, which means that this isn't a pointer. You can see here if I go back to dump 2, we went to 59BF50, and then dump 1, we went to the ECX address. But yeah, dump 3, or I'm sorry, argument 3 is not a pointer. We can make the assumption that that's actually the data size. And looking at the content of dump 2, the second argument, this looks like a bunch of deobfuscated code. And looking at dump 1, not so much. Seems to be a lot of zeros. So what we're going to do is we are going to execute till return. And let's look at that obfuscated code dump when we do that. And we'll give that a second. And okay, it just finished. And what we see is this IP. We see this kmaster logs. We see remcoast.exe. So we actually are seeing data decryption. So now what we're going to do is we're going to now test that in CyberChef by pulling out the key, the KSA, the key from the KSA function, and we'll take the encoded bytes that we were just looking at a second ago and see if we can, in CyberChef, we can decrypt it. Kind of like a validation piece after seeing what we saw here when executing in the debugger. So let's go ahead and let's restart this. And let's go ahead and let's just run that again. And we land back here. And same kind of thing, I'm just going to dump those 3 arguments to our dump window. We'll start ECX. Dump 2 is our ESP plus 4 argument. And ESP plus 8, we'll dump that into our dump 3, which we know is the size. And so we're asked to copy the encrypted bytes. So let's go to our dump 2 where our encrypted code is. And we know looking at, since we know ESP8 is the size and we see that's 1F9, we can go ahead and highlight and follow on the bottom left here the amount of bytes that we have highlighted. So let's copy this all the way to right here. Right click, binary copy, and let's go into CyberChef and let's look at the RC4 operation and let's just dump the input for now. And then we're asked to now go back to our static function because we want to take a look at KSA. We want to look at the actual encryption key. So same kind of thing, let's grab the address, let's hop into Binary Ninja, and same kind of thing, we're asked to evaluate the calling convention, which is a this call, and the number of arguments. So again, we can just kind of go back to our assembly and we can see that there are 3 arguments. This one seems to be 2 stacks, and you have ECX moving into ESI. So there are 3, same kind of thing. ECX is being used since it's a this call, and we have 2 arguments on the stack. So now with that address copied, let's go back to our dynamic VM and let's restart. Let's set a breakpoint on the KSA function. And let's go ahead and let's run that. And now we're at the KSA function. So what we're going to want to do now is, again, just look at all of the arguments. So we'll start with dump 1. We'll take a look at what's in ECX. Should I copy that? We got a bunch of zeros, so that's most likely not the key. Let's take a look at the first argument. Okay, we have a little bit more bytes now. Good chance that maybe this is the key. And then dump 3, which seems that this is also kind of like what we were seeing earlier. This argument is the size. This isn't a pointer, it's taking us to this 20 in the dump window, which is the amount of bytes in size that this key is. So then we're asked to copy the bytes for the decryption key. So let's go back to our second dump, the actual key content, and let's, knowing that 20 bytes is the size, let's copy 20 bytes. Where am I? binary copy. Let's open up CyberChef again and let's dump our passphrase. And let's make sure we set the input to hex. And there we go. So I didn't mean to do that. Okay, there we go. So input's hex, key is hex, output is in Latin or ASCII. So there we go. So we're seeing now we were able to actually just validate what we saw in the debugger because we were able to actually pull out the encrypted um, content of or the encrypted code, and we were able to actually pull out the key as well with from the debugger and by looking at the PRGA and the KSA functions in Kappa. So there we go. We can see the same thing, the IP, the kmaster logs, and some other things here that are of note. Screenshots. You can see Remcoast there. But yeah, that's it. So thank you, Anuj, for another good lab.